All right. Hello. Hello, everyone. Is there an everyone? We'll find out soon. We got Dr. Mocked. Elongate. Elongate. Okay. Morning. Good morning, those who are here. I appreciate your greetings, as bizarre and random as they may be. It is good to be. It is good to be greeted. It's good. That's me. All right. Well, I think I'm assuming you all can hear me and hear me say the words and the things. Those are useful things for you to hear, probably. Wrong account. Oh, that was you. You were Doc Mocked. Oh, I see. I see. That's okay. You could be on other accounts if you wish. I am not. I don't necessarily require people who join the live stream in my classes to like have like an account with like their name. Some people like to have their handle there instead. It's all good. Well, thank you for being here, and thank you for letting me know. Hopefully, you can hear me. Um, I got a lot to get through today, so I'm going to just sort of jump right in. Um, if there's questions, as always, just throw them in the chat, and I'll do my best to address them. But I'm going to do a little bit of kind of housekeeping today. So today is kind of a special lecture in that, for a bunch of reasons, but first and foremost because today is the first lecture after you all have submitted like some more work, right? You had your first week, right, where I gave you basically like one assignment. It was mostly just setting up your environment. It really wasn't a lot of like stuff. This last time I gave you a little bit more, and hopefully most of that was review. But I noticed that there was a fair number of people who waited till the very last second to try to get their work done, and hopefully the lesson has now been learned. You should not do that in this class. It will punish you. You will be punished if you wait until like Tuesday at like 6 or 7 o'clock in the afternoon to start trying to bust out the work. Like you're probably gonna not make the deadline. There's a good chance you're not going to. And you might even be able to get away with it a few times, but more often than not, you're not. And so I always say this. I say it in the very beginning, and I'll bears repeating now. Start the work as soon as you possibly can, because inevitably you're going to run into a problem. And there's lots of things you can run into problems with. It could be your compiler, you get compilation errors that you don't know. It could be your dev environment has a problem. It could be autograder feedback you don't understand. It could be whatever. It could be tons of stuff. There's like lots of reasons you're going to have a problem, but there's a good chance you're going to have a problem. When that happens, you don't want to be like hours away from the submission no longer being accepted. All right, so start early, hit the problem early, get help early, solve problem, and then you get it all done before the due date. Okay, so that's just my reminder. Most of you actually did fine. I just wanted to reemphasize that for those who maybe have never had me. Maybe you had a different kind of setup in a different class, and this is your first time getting that experience, so that's how it'll go. So you really need to get on it quick, soon. Don't wait. Other thing I wanted to remind everybody about is how I have things organized in Canvas. So, like last week and the week before that, obviously the live streams are recorded. After the live stream is over, every week you're going to see one of these things pop up that's the live stream recording. I always kind of encourage everybody to just subscribe to my YouTube channel because then I schedule out the live stream, and so then you'll get a little notification for when it's about to start so you don't forget. But if you don't want to do that, that's fine. The other option is I put a link to it right here. So it's not here this week because I'm literally in the middle of doing the live stream. But as soon as this live stream is over, I will post another page here on our module, and it will be this, and it'll have a link to the live stream recording. Um, Most weeks, and today will be the first of these situations, I will either review the homework from the previous week during the live stream, or I will post up another video that is a walkthrough of all the work from the previous week. So I don't have enough time to get through the walkthrough today during the live stream. So guess what I'm going to do? I'm going to post up a walkthrough video. Where that walkthrough video is going to live, it's going to live in that live stream recording page. right? So I'll click on the one from last week. So you'll go in here, and this is what it says, and here's the link to the live stream, okay? If I have a walkthrough video for the previous week, it will also be in that same spot. The walkthrough videos, for sort of obvious reasons, those aren't public videos. So the only way you'll get access to them is by clicking on them from inside of my page, because they're not listed in public YouTube. So you have to like have the specific link to get there. All right. So I'm just letting you know where to go to find it. So at the end of today's lecture, um, you're going to see the live stream recording thing pop up here. You'll click on that. There'll be a link to the live stream, but there'll be another link right below that to the walkthrough for what was last week's stuff. It was Cubic Object and the comic book collection. Okay, so if you ran into problems with those, you weren't quite sure how to do it, I have a whole video walking through the whole thing. I'm going to post it up there for you, and you should watch it. Even if you knew how to do it and you got it 100%, I still encourage you to watch them because I think it's useful for you to get that kind of perspective. It might just be a different perspective on how to approach the problem, and that by itself could also be helpful. Okay, so just giving you hints on like, this is how the class is set up. Also, at the end of every lecture, I also post up all my lecture code. So here's the one from last week. So if you click on that, it's just all the code I wrote during my lecture. So I post that immediately afterwards. I don't clean it up or anything either. It's just literally whatever I wrote during the time. So if you watch the video, maybe it'll make sense. If you didn't watch the video and you just look at that code, it might not have the context you need. So they go well together. Oh, I can't hear. Oh no, have I been talking without being audible this whole time? I feel like more people would have said that. Maybe you meant to say can and you accidentally put a T in there. I'm going to go with that for now. But thank you. Well, I'm going to check. Now I'm scared. I'm checking my stat. It looks like I'm good, but I always check. Um, okay. Oh, you're just kidding. Oh, thank you for freaking me out. I don't want to be that person who's like talking, like he's just like, well, let's see if I can pantomime my way through this entire lecture. Like, don't do that to me. That's stressful for me. All right, good deal. Okay, so that's sort of the kind of housekeeping-y stuff. I have two main concepts I'm going to be talking about today. Today, like I said, sort of a special day because people are learning kind of how the class operates, but B, today is the day when I first get to start introducing new stuff. All right, so up to this point in the class, it's all been basically review. Right, I haven't really introduced any new concepts. Everything's really just been review of concepts that I sort of expect you to already have, but now in C++. So a lot of it's just been getting used to C++'s syntax. Today we start new stuff. Okay, so first new thing I'm going to start with is actually not going to be new for some of you. So any of you who took CCI 20 with me, this is going to be a little bit of a review. For anybody who hasn't, hopefully this will be useful, but it's a tool that I like to demonstrate to everybody. I use it a lot, and that tool is called Flowcharting. Okay, so you'll see that we actually have an assignment dedicated to it today in our work this week. This, just as a reminder, this is a Canvas assignment, right? You're not doing this. This is not an auto grader thing. There's no programming for this. Okay, so Kyle. Oh no, Kyle. Yeah, we'll talk about that later, but that one's a programming thing. But first, I'm talking about flowcharting. So if you don't know what flowcharting is, don't worry. I'm going to talk about it right now. It's a diagramming tool. It's utilized by several industries, not just programming, but it is used by programmers. And it's basically a way for you to model out an algorithm. Okay? It's just like a visual way of modeling out an algorithm. So I'm going to walk through it today. I'm going to showcase how you can do it. I'm going to introduce a tool that I like to use for my flowcharting. You're pretty much always going to see me use this tool because I'm not a great at drawing things, and this tool is really nice. In fact, you can find the tool very easily by clicking on the flowcharting assignment, holding out here to the bottom right here, and this is the one right here. In fact, I'll just click on it and it'll open it up. So it's called diagrams.net. I think it used to be called draw.io. I don't know, they changed the name. And basically, it's just a tool. You can run it in your browser. It's free. It doesn't have any ads. I've been using it for many years. I love it. So when you click on it, you'll go here. The first thing it's going to ask you to do, what kind of diagram you want to do. You can click on that. You can pick. I'm just going to do a blank diagram. They actually have a whole bunch of like templates. I don't ever use the templates in my class, but you can see they have tons of different things. I'm going to just leave that as untitled diagram. I'm going to hit create. Oh God, it's going to make me open something up. That's super useful. I don't want to put this somewhere. Where do I? Oh God, where am I going to do this? I'm just going to put this here for now. I already have one made. I just wanted to show you how it works in the thing. Here, save. Sure, I don't care. F. That's what I named it. F. The one and only ad you ever see in this tool is this thing that just popped up right here. It says Get Desktop. It's the only ad you ever see, and it's really just so if you want to download the actual client to run on your local computer instead of running it in a browser, you can. That's actually what I do. But I wanted to showcase you can do this in a browser. There's nothing special or magical about doing it in the browser or on your client. They look exactly the same. So you can see here's what it looks like in the browser, right? And then you can grab these icons and drag them in here, and then you can draw a flowchart, which I'm going to do right now. Um, I'm not going to do it in the browser though. I'm going to show you how it looks on the desktop client. Here's what it looks like on the desktop client. They look exactly the same. See how it's exactly the same experience, except over on the right there's these weird things I've never seen before. What are these? This must be new. I don't use any of this. Is it something I can use? Oh, it's just some sort of like extra pane for keeping track of stuff. Oh, that's kind of neat. Maybe I can do it here. I've just never turned it on. Maybe it's in the view. Anyways, all the important features are there. Notice how they're exactly the same depending on which one you're in. It's irrelevant. So you're going to see me do everything on the desktop client, but you absolutely can do this in a browser if you want, and that's fine. Or if you really don't want to do it at all that way, you're also welcome to draw your flowcharts on paper and pen or some other tool. I actually don't really care. Um, in the end, I'm just going to have you submit flowcharts to me periodically throughout the semester. And it's my way of basically getting you to show me that you have thought through an algorithm, right? It also lets me talk about an algorithm at a high level without having to get into the code, right? So I can basically give you an algorithm without giving you any code. And then your job will be to be able to use that as the way that you're going to, put code to the text editor. Um, so today I'm going to model out a flowchart just to demonstrate how it works. As you can see right here, if you go over to the left, there's a couple of sections, and one of them is called Flowchart. And these are all the symbols that this tool has for flowcharting. Flowcharting is a full-on, like professional grade system for diagramming processes. And like I said, it's not just used by programmers. Engineers use this, marketing teams use this, project managers use this, programmers use it. I mean, it's a kind of very versatile system for diagramming things. Um, and and it actually has a lot of different symbols that you can use that mean very specific things. I'm not going to try to do that to you. Not. I'm in this class, you will only ever need 4 of these symbols. Those are the only 4 symbols that I ever use, and I've noticed that they get us through pretty much any kind of setup we really want to do. So those are the 4 I'm going to expect from you, and I'm going to demonstrate how to do them right now. And the way I'm going to do it is we're going to we're going to make a flowchart diagramming the process that I go through for going to bed every night. Okay, so it doesn't have to be applied to programming. I'm going to use this in a little bit more of a non-programming sense, because it really what this tool or this system does for you is allows you to diagram things, right? And diagramming an algorithm. And algorithms exist outside of programming. You use an algorithm to do almost everything in your life, right? So we're just going to use this to diagram the algorithm of going to bed. First symbol you need to know, the oval. Okay, this oval right here. In the tool, if you use this tool, they actually call it start, which is convenient because the oval represents the beginning. It also represents the end of your flowchart. So it's the first step should be an oval, and the last step should be an oval. Okay, so the purposes of our thing today, I'm going to say this is going to be the start. I'm going to say, decide to go to bed. Right? That's going to be the first step. I'm going to make that a little bigger so that I can actually read it. There we go. And then you can kind of make these a little better. There we go. And you can position them. Hopefully you're seeing some of the benefit already. I can just drag and drop things around and make things bigger and all that good stuff. All right, so that's the first step. The last thing I'm going to do, and then you can copy and paste. That's the other nice thing here. Right? The last thing that I'm going to do in this diagram is I'm going to, I don't know, go to sleep or something, right? That's so in the beginning of my process, I'm going to decide, hey, I need to go to bed. And at the very end of some series of steps, I'm going to go to sleep. Okay, so that's the end of this decision train. Again, if you had 20 with me, you've gone through this procedure. I want to get through this quickly, so I'm going to kind of just roll through it. I might ask for some participatory steps. In fact, I'll ask right now, and you can put it in the chat, and we'll hopefully the lag will catch up. Tell me some stuff that you do on your journey to going to bed every night. You know, I'll share a little bit of our insights about how we do things. I'll share with one of the things I do every night before I go to bed. When I decide it's time to go to bed, one of the things that I do every time, no matter what, is I get into my pajamas. It's a rote step that I do every single time. When you have a step in your process that is something that you will do exactly the same way every single time you do that process, use a different symbol. The symbol that you use for those sort of regular steps is the rectangle or the square, right? So I'm going to put that in here. The square / rectangle is used to demonstrate a step that just always happens, and it always happens in a very specific way, right? It's just sort of like a thing that always happens, and there's no changing it. Let's put it that way. It does not require input. It doesn't require anything else. It's just a step. So for me, I'm going to say put on PJs, PGs. All right, there we go. There's one of my steps, okay? And again, I'll make it big enough for me to read. One of my steps is I put on my pajamas. Any others? Brushing teeth. So always happy to see brushing teeth make the list. Is also something that I do when I go to bed. So let's do it. Brush teeth. It's an important step. I strongly encourage, if you ever meet me in person, that you do this step. Okay, I don't want to meet you if you don't. This is not something you're doing on a regular basis. You continue to just come to my virtual office hours. I don't want to be arm's length from you. All right. Listen to something that makes you sleepy. All right, listen to some music. Let's do it. Listen to music. Listen to some. Wait. I have to qualify that. Sleepy music. Listen to some sleepy music. All right, here, I'll put it over. Yeah, right here. That looks good. What else we got? Eat a whole bag of extra hot Cheetos while watching Schitt's Creek. You have a very different life than me, but I will say I love Flaming Hot Cheetos. I've reached that age where like I can't actually have them, but they are like sort of my guilty pleasure. I love Flaming Hot Cheetos. They're so good. And then like my stomach later is like, you've made a mistake, but my mouth is like, no, you did not. It's just one of those situations. You must have an iron stomach. Yeah, exactly. I can't do it. I mean, I do, but I shouldn't. Like I've reached that age. I'll do it. I'll even put it in here because I love them so very much. Eat. Flaming Hot Cheetos. Probably spelled that wrong here. And you can make this a little bigger. There we go. Okay, gotta eat the Flaming Hot Cheetos. Okay. I'm gonna share a step that I do every night in my house. Another step that I have is that, well, see, I have a cat. I have two cats actually, and one of my cats is a responsible eater, and the other one not so much. And if you put food in front of that other cat, they will partake. It does not matter the amount. And so one of the steps I have every night before I go to bed is I need to check to make sure that there's enough food in the cat bowl to, satisfy my chunky cat. Because if that food bowl is empty or very near empty and I go to bed, guess what I'm going to hear in the middle of the night, like at 3 o'clock in the morning? There's going to be no food. They're going to want the food, and then I'm going to start hearing meow, meow, and scratching on the door and the knocking of things off my shelves, and I don't want that. And then I'm going to have to chase the fat cat around trying to make her shut up. So to avoid that, to be responsible, one of the steps I have in my nightly routine is checking the cat food bowl. Now, in that particular situation, right? That's not something that's not like information that I have on hand, right? Like I know how to put on PJs. There's no decision point here. There's nothing I'm making a decision about. I know how to brush my teeth. I'm pretty sure I know how to listen to music, right? And the Flaming Hot Cheetos, I mean, I suppose I could go make sure I have some Flaming Hot Cheetos, but let's just be honest. You just always have Flaming Hot Cheetos. If this is something that's part of your bedtime routine, you just have a regular supply of them sitting in a bag, just like a huge bag, and it never goes empty, right? But the cat food bowl, that's different. I might not have enough food in the cat food bowl. So in those situations where your process has a situation where you need now to collect some input that you do not have on hand, right? That's a new symbol. New symbol that we use for input collection is the parallelogram, right? Parallelogram. So the parallelogram denotes input in a flowchart. Technically, right? If you want to go talk to the flowchart police, it's also used to denote output of a process. I pretty much never use it for output. I pretty much always only use it for input. If you want to use it for both input and output, go nuts. That's fine. I'm not going to ding you for that. Usually for output, I just use a regular, the regular square or rectangle, and I pretty much reserve parallelograms for input. In this case, I'm using it for input. I need to check the cat food bowl. Okay, so let's grab that. Oh, let's do this. Oh boy, and this is the only thing about the parallelogram is it's kind of hard to hear. Sometimes I do this and that. Oh, that makes it a lot better. And then I can make it a little less horribly big. Okay, so there we go. Gotta check that cat food bowl. Okay, so that's what you use the parallelogram for. Is at least input, but you could also use it for an input and output. Okay, have an have an existential conversation with my partners till I fall asleep. Actually, I do that as well. I'm seeing a lot of overlap here, Raquel. You're also into the flaming hot Cheetos and existential conversations, and I know you play chess. Things are going well. We're going to get on very well. All right. So now that I've collected the input from about the cat food bowl status, right? I need to make a decision because if the cat food bowl is near or is empty or near empty, right? Then I'm going to need to put some more food in the bowl, right? But if it's got plenty of food in it, then I'm not going to do that. So basically, I need to make a decision based on the input that I just got, right? So I'm going to use this input to make a decision. This is the last symbol that I use in my flowcharts, and this is the decision symbol. In flowcharting world, that is the diamond. You can come over here, and they literally call it decision in here, so that's good, right? So in this case, I might write something like, I don't know, cat food bowl empty, question mark, right? And we'll make that old man visible size, right? Here we go. Whee. Okay. Oh no. There we go. It's a little hard to get that one, the diamond, because it's a weird shape, so it sometimes takes up more space than I wish it did. It is what it is. All right. So then we're going to make a decision. Now that decision will then dictate what we do next. So let's just assume that we are going to have to put some cat food bowl in. So at some point, it's possible I might need to fill up the bowl, right? So let's do that. Put food or fill up the bowl, right? That's one of the options. But if I don't have to do that, then I can just move. I can just bypass that. If there's already plenty of food in the bowl, I can just bypass that step and go straight to the next step. So what's another step I might do? I don't know. Did anybody else? Check locks. Check locks. There we go. Good. So let's check the locks. I'm assuming you mean like the door, like lock the door, right? So let's just do that. I'll go like that. Lock doors. All right. Lock the doors to the house. Make sure that the bad people don't get in. One of the things I also like to do is I like to make sure that the lights get turned off, right? So here, like turn off appliances. So turn off. I'll say appliances. Like your TV, your lights, the flamethrower you have running in the background. Those things, you know what I'm talking about. All right, so that kind of stuff. You might want to turn off those appliances, lock the doors. Anything else? What else we got in here? I want to add existential conversations to the list. For me, it's more like where do I put the existential dread? Do I put it up here? Maybe down here somewhere? I don't know. This is good. I don't want to take too long with this, so let's do this. So this is the kind of the beauty of the flowcharting system. So once you've identified, it kind of forces you to identify all of the steps that you're going to need to make your process work, right? So this is it. This is sort of its main benefit is it allows you to do some planning. So this is what I like really promote this system for when you're doing your programming work, because if you do a flowchart before you start writing code, then you have a plan for when it's time to write the code, right? You're not just sitting down at the text editor and just like, let's hope I trip over an answer. Like you actually have a game plan. It also lets you plan out the order of operations, right? Case in point, you would normally like kind of start here, and I'm going to draw some arrows that go from each thing, right? And each one of these things seems pretty good. I'm obviously going to need to check the cat food bowl before I can make a decision, right? So clearly this has to happen before this, right? But here's one that maybe doesn't make any sense. My instinct would be to go here, here, and then here, right? But look, if I turn off all the appliances, Well, that means I've also turned off the lights. Does it make sense that I would want to turn off the lights before I lock the doors? Do I want to stumble around in the dark looking for a door? No, that's kind of a silly thing, right? So gives me an opportunity to kind of review what I've done and go, okay, you know what? This probably should happen before that. And now I've identified kind of a logic problem, right? In my flow chart, identified an algorithmic problem, and now what did it cost me? It took me like 2 seconds to flip those around. I've written no code. I've made no commitments. Very easy to change a diagram. Less easy when you've written a whole bunch of code and now you got to undo a bunch of it because you found yourself in a wacky spot. All right. So I'm going to go with this. I'm going to say turn off the appliances. I'm going to also say there's one more step here. One more step. I probably want to get into my bed. I don't want to just fall on the floor. So get into bed. Right. I do that pretty much every night. Pretty much every night. You know, but some nights, who knows? You might fall asleep on the couch. I try not to do that because then I wake up with a neck ache. All right. So here we go. Now we're going to start at the beginning. And I'm going to draw some lines. And this is just dictating, the order of operations here. Okay. Here to there to there. Now, I don't like it when my arrows do this weird dashy thing. The OCD in me doesn't like that. So I'm going to try to line these up nice. Please, if you do use this tool, let the arrows be straight. Don't make them crooked. It makes me sad. I have a little sad moment when that happens, right? Now, here's the thing that I will point out. This is nice. So when you have a decision point, obviously there's more than one thing that could happen here, right? So if the answer to this question of the cat-food bowl being empty is true, right? So if the answer is yes, right, then you're going to want to fill up the bowl. So I can make a little line right here that tells me what to do after that. In fact, it's getting a little scrunched up. I'm going to move that over to the left. There we go. So if the answer to that is yes, then this is what we do. And after that, then I'm going to go try to lock on the doors. Right? Okay. Oh boy, that got messed up. Okay, here we go. We're getting there. We're getting there. However, if the answer to this was no, right, then I don't need to do this step. So in that case, I would say there's actually another one, and we can just go straight from here to here. We could say no, right? We can come over there, and then that's our process, right? And then we can come over here, turn off the appliances, get into bed, go to sleep. All right. So this is what I'm talking about when I say a flow chart. All right. This is just kind of a nice high-level demonstration of the tool. It's demonstrating all of the key symbols that I'm expecting you to know in this class. So again, the review: oval is for the beginning and the end. Rectangle or square are for the kind of just steps that always are kind of occur the same way, right? There's no that doesn't require input or output. It's just do a thing. The parallelogram is for input or potentially output. I pretty much always use it for input. And the diamond is for a decision point. All symbols should have at least 2 arrows connected to them. All symbols do, except for the first and the last one, right? The first and last one are the only ones that really should only have 1 arrow pointing out of them or pointing into them. That's it. All the other symbols should have a minimum of 2 arrows, 1 pointing in and at least 1 going out. The decision points can actually have more than that. Decision points can have 1 or maybe even multiple things going into them and then multiple things going out of them. All right. But there should never be a situation like this. And let's say I got rid of that. So this would be a bad flow chart right here. Because look, if you follow along, you could end up in a situation you end up here, right? And then you don't know where you're supposed to go after that, right? So if somebody turned this sort of flow chart into me, this would be something I would mark off for because it's incomplete. It's an invalid flow chart. Flowcharts need to always only begin in an oval and they have to end on an oval. If it ends on something other than an oval, then that means we got an incomplete problem here. Okay? So I'm just trying to showcase how I kind of expect you guys to do this stuff. All right. That's what I do. Yep, that's what I do. Check those locks and then have an existential dilemma right before you go to bed. That's what I usually do. All right, so this is what I'm looking for, something along these lines. This week's homework, I'm going to review back to the homework and sort of review what I'm expecting from you all, but I wanted to at least demonstrate what a flowchart is, how you can use this tool if you want to use it. Also, if you want to use this tool, the other big advantage here is that you can just go up to the file, go File, Save As, or Export As, and here's all the things you can save it out as. You can save it as an image or a PDF, and then you can submit that in Canvas, right? Nice and easy. No muss, no fuss. All right, and you can save this on your computer as well, which is what it made me do a minute ago anyway. And so you can pull it back up and continue to modify it if you need to. So that's pretty nice. All right. Any questions about flowcharts before I go away from them? I guess it's worth mentioning right now. I don't want to forget because this is kind of a thing. So here it is in flowcharting. This week your homework will be to flowchart. Actually, you're going to build a flowchart for the very first week's program, basically. So or yeah, the one where I had you do the one that we did in class, where you were flowcharting out your pay, right? So if you get overtime pay or regular hourly pay, right? So that's basically what I want the flowchart for. Again, not writing code. I don't want code. I want a flowchart. So what you're going to submit is something in Canvas down here, just like I demonstrated on day one, how to submit a flowchart in class, or how to submit something in Canvas and not in AutoGrader. Something I do want to mention, and this is sort of a distinction between when you flowchart something for a piece of software versus something that's a little bit more high level. The reason I use this as the demo for this is because this should be high level. Notice how I don't have in the put on PJs, I don't have like put on socks, put on, the particular kind of pajamas I'm wearing that night. I don't have like the color of my toothbrush here. Like I don't have a whole bunch of the little tiny details. Why? Because the basic idea behind a flowchart is that you should be able to hand that flowchart to somebody else, and it should give them a nice high-level overview of what this process does. If you start adding tons and tons and tons of little itty-bitty detail into it, it starts to stop being useful. At that point, you might as well have just written the code or just done the thing, right? So it's useful for planning. And there's sort of a gentle balance here between planning, the kind of planning you might need to actually get your thing done, and also producing a document that you can share with other people, because that's its other main utility, is being able to share an idea with somebody else, have them quickly look at something and get a good idea of how it works without having to read a big long thing. And so I've noticed what a lot of people tend to do when they get into their flowcharts for programs is they start putting steps in here that are like, they'll put things like, define data type, define function, I don't want any of that. Don't put any of that junk in here. All right, I don't need that. I need to know what your program does, not how you set it up. Right? I'm not interested. That the flowchart should tell me the flow. Definitions of things aren't how your program flow. Those are just data structures. That's just like if you make a struct, if you make a custom data type, cool. I don't need. That's not part of the process. If you use the custom data type somewhere in here, sure. If you have if I was writing a piece of code that was like, I don't know, had a PJ object, right? I might say call PJ object, call PJ dot put on, right? That's a part of the flow. Not I defined a data type called PJs and here's all the member variables. I don't need any of that. That's way too much detail. Okay, so I'm trying to make a little distinction here. It should be demonstrating how the process works, like the flow of the process, not how it's architected. There's a little bit of a difference there. Okay. Enough of that. Let's move on. We're moving on. I don't see any questions about this anyway. Here, do I want to save this? Here, I'll save it. Save. Cool. So, today, we're going to jump into the first, kind of really new, in my opinion, very interesting part of the class, this new concept. And it has to do with efficiency. So let's start talking about it. It's going to be a little bit C++ specific, but it's also just sort of core concepts that I expect people in computer science to know about. And you probably have had very little exposure to it up to this point. So let's do it. Is this already here? All right, cool. I already got this going. So we're going to talk about... Did I spell that right? I don't know if I did. Who knows? We're going to talk about efficiency. So today... we're gonna do. Well, first, I'm gonna do a little review, and then I'm gonna introduce some new things. Okay. So here's the little review, and you're all gonna love it so very much. Oh yeah, it's still here. We're still doing this. Oh yeah. Just in case you thought you were free, you'll never be free. Hold on. Uh-oh. My standing desk wants to stand, but I don't want it to stand. Okay. So, review time. All right. I'm gonna write some code really quick. All right. So here's the code. I'm gonna say my int, right? And I'm going to put, I don't know, 42 in there. I'll put 5 in there. Let's do something really small, okay? So hopefully you all, this has not blown anybody's mind right here, right? I'm declaring a variable called my int, right? And I'm initializing that variable to 5. So let's review what that does, right, in RAM. Because remember, when you declare a variable, I know I've talked about this before and you're probably sick of hearing about it. Today's a day where it's always important, but today becomes all extremely important that you understand this relationship. That's why I emphasize it so much, right? Data type, variable, initial value, right? Initialization. Variables are just symbols for address spaces in RAM. That's all they are. Okay, so if you go back to our RAM diagram, remember when I did this, I'm going to put this down here. RAM is really just composed of this top row, the address, and the value. Those are the only two things that are in RAM. I always put this variable thing down here just for reference purposes. This is not in RAM. Your CPU does not give a crud about your variables, right? When you're running code, this disappears. This is for the human being. It is not for the CPU. It is not for the computer, right? Because human beings like to have like little symbols like this that mean things to us, right? The CPU, you know what it wants? It wants addresses. That's what it wants. So when you make a variable, all you're doing is you're creating a symbol that represents an address location. So when I wrote that line of code just now, what actually happened was for my int, right? We're going to pretend like what happened was in RAM, the operating system allocated some space in RAM, and we're going to say it was address space 100. It wasn't, but let's just say it was, right? And then what's the next thing it did? It initialized the value of that address space to 5. So after that line of code ran, you can kind of think of this as being what's inside of RAM. Okay? So the myInt variable represents this address location, and this is the value stored at that location. All right? Hopefully everybody's with me so far. No, not blown anybody's mind. Right? Now that relationship is very important because when we start doing things like this, now we got to talk about how does a variable get used when you use it in your program. Right? So if I do something like this now, okay, let's talk about what actually happens when you do this line of code right here. Okay, so this created the variable and put a location in RAM and stored a value at a certain location. That's what this line on line 13 did. But what did this line do? Well, remember, cout is an object, right? So this is just an object. We talked about this last time a bit. This is the insertion operator. This is an operator. It operates on this object and this object, right? This variable, right? It operates on two things. Sort of like how if I said 7 plus 8, right? These are operands. 8 and 7 are operands, and this is an operator. The operator operates on these two values, okay? So when that happens, the same thing is happening here. This operator is operating on this and this. And how does that operator work? This operator will take the value of whatever is in this spot, and it will assign it will direct that information to this object, which is the output buffer. Okay, so just getting your head wrapped around that's what's happening right now. So if that operator is operating on this value, that means it needs to know what this variable represents. So whenever your variable gets used, right, another way you could think about it is it's getting evaluated. When you use your variable, what's really happening is it's getting evaluated. And evaluation is a two-step process. It's a two-step process. So let's talk about that. On line 15 in this code right now, when it gets to the part where it needs to evaluate myInt, this is what's going to happen. You can kind of think of it as two steps. Here's the first step, and here's the second step. So the first step is that it went, okay, you just referenced my integer, or myInt, right? First step, I got to find the address location that's associated with that variable. In this, on my little diagram, that's address location 100, okay? Second step, I got to go find the value stored at this address location. And this is the value that I'm going to return and give to this operator so it can do its job. Right? Same thing's going to happen over here. If I said, I don't know, int x equaled myInt plus 8 or something like that, right? Same exact thing happened, right? I'm declaring a variable and I'm using an assignment operator. This is an operator. What does it do? It takes everything on the right-hand side of it, makes a copy of it, and it assigns that value, the evaluated value of on the right-hand side of it, to the left-hand side of the operator, which will be this variable, right? Which means that it has to evaluate everything on the right-hand side. It's easy to do this part. 8 is 8. There's nothing to do there. But this is a variable. So how does it know what this variable's value is? Well, it has to do an evaluation. It has to go into RAM, find that variable, find the address location first, and then second it has to find the value stored there. It's a two-step operation. Okay, I'm doing this for a reason. It's not just to torture you. Today we're going to start by talking about two new operators. Okay? The first one we're going to talk about is called the reference operator. The reference operator in C++ is denoted by the ampersand sign. That is the reference operator. What does the reference operator do, you ask? Don't worry, I'm going to tell you. So, the reference operator will allow you to reference a variable, a variable's address. Okay? You can use the reference operator, and again, this is an operator, you can think of it as sort of like suppressing the second step in an evaluation. So when a variable gets evaluated, it's a two-step process. If you use the reference operator, it will only do the first step. It won't do the second step. All right? So in this case, if you did something like this, here, we'll just do cout here again. If I do my int here, like I did last time, right? And here, let's run it. Let's run this guy. G++. Efficiency. Okay, so what's happening here? I'm going to get 5 twice, right? Why? Because it evaluated it here all the way and here all the way. If I want to use the reference operator, though, all I have to do is put that symbol in front of a variable, right? And what I've now told it to do, what this operator does, is it suppresses that second step. So now, instead of doing a full evaluation of this variable, right, it'll actually only get to this step, and then it won't do the second step. And so what it's going to see out, what's actually going to get passed over to see out, is the address location of this variable. Okay, so let's see what happens. All I did was I added that ampersand. That's literally the only thing I did. All right, compile, run, and there it is. Okay, that's what I get now. I get this number. Okay, and remember, addresses are always just numbers. That's all they are. They're just big numbers. Okay, now I write them as these small numbers in my RAM diagram just for simplicity, but they're actually quite large. They're large, big numbers. Okay, just in case anybody is confused or scared or, hey, what the heck? Why is this? Go away. All right, thank you. They're like, what is this? What's 61FE? Numbers don't have letters in them. Well, they do when they're in hexadecimal. And just in case you don't know what hexadecimal is, don't worry. Don't worry. I'm going to show you. Okay. Actually, before I do that, I use this as an opportunity to talk about this a little bit. So if I keep running this program, you're going to notice the exact same address keeps popping out. See how the same exact hexadecimal address value pops out every time? Okay. That's actually a feature of MinGW. And this also kind of demonstrates why, that reinforces the thing I talk about with the operating system. So remember who's doling out RAM to your program. It's the OS, right? So right now I'm on Windows. I'm on Windows doing this. I'm using MinGW to do this. I've noticed that on Windows using MinGW, I think it uses some virtual RAM. And it's like for caching purposes, I think it actually just allocates a bunch of it over, and it's always the same. That's why you always get the same value back. That's actually not how most operating systems do things. Most operating systems, every time you run the program, the operating system will find a spot in RAM and it will give you out a new spot in RAM. So to help demonstrate that, here's what I'm going to do. I'm going to actually run this exact same program and I'm going to do it in Ubuntu now. So now I'm in a completely different operating system. All right, and now let's run this. And also, if you're on a Mac, this is probably what you're more used to seeing, right? You see how the slashes are going a different way. And also, you're not used to seeing a.exe. If you're on a Mac, you'd be getting a.out. Or if you're on a Linux machine, like I'm doing now, you're getting a.out. Okay, so here it is. I'm going to do a.out. Right, and here we go. And now look what I get. 5. And first off, look, completely different number. If I go back to this and do it in a.exe, right? So first off, it's a smaller number, so that's curious all on its own. But then over here, it's a bigger number, but it's different. And now also, here's the thing. If I run it, notice how that number changes every time. It's a different number every single time I run it. So the operating system is doling out different RAM, spot in RAM every time I run the program. Okay? So I just want to say, when I tell you these things, it's true, but always keep in mind that, like, the operating system is the one who's in control. So depending on your OS, what RAM you get is, you don't get to control that. That's something that the OS is giving you. You're at the mercy of whatever the heck it is they're doing. Also, since I know some people get a little scared of this is hexadecimal. Okay, if you don't know what hexadecimal is, here, let's do it. You can go up to your calculator program, right? I'm going to use the old calculator program in Windows. You can go over here, you can go to Programmer, right? They actually have a programmer mode, which I think is awesome. And hexadecimal is just a different way to represent numbers. That's all it is. Okay, it's to make it so that you don't have to be quite as big. You can actually represent the same number with a fewer number of digits or fewer number of symbols. It's a very common way to do it. So here's what I'm going to do. I'm going to copy this. I'm going to come over here, and I think I can just paste this in. Oh, it didn't like that. Oh, can I put it in hex? Okay, I put it in hex, and then can I do it? There it is. There it is. So there's that number, same exact number. You can see it right there. Number, right? This is what it looks like in hexadecimal. This is what it looks like as a decimal value. It's just a big number. That's all it is. Like I told you, they're actually big numbers. This is the actual RAM address location of where it stored that value on my computer's RAM stick. Right? That's where it is. It's just a number. So every time you see one of these, so if you ever see something like that pop out of your output, you're seeing an address location. This is like the dead giveaway that you're doing something with an address location and not like probably a value you were meaning to do it. Okay. That is what the reference operator does. So one of the things you can think of it as is it gets the content. Let's say get the. I wrote it down over here. I'll make sure I say it right. There you go. That is what the reference operator does. Okay. That's our first operator. Right. Also, keep in mind this is a unary operator. I know a lot of times when you think of operators, you think of like 8 plus 9 or something like that, where the operator operates on two things. Okay. Operators don't have to always operate on two things. It's common that they do, but they don't have to. Case in point, you've already used a unary operator in your classes. If you've ever done something like this, I don't know. Not my bool. You ever done that? Ever used the not operator? That's a unary operator. It's an operator that operates on a variable, only one variable, right? Right. Reference operator, same exact thing. It operates on one particular variable. I have long awaited for this moment. My life has now been fulfilled. Perfect. That's what I'm all about, life fulfillment. All right. Second operator. Let's talk about the second one. Now, this is the reference operator, so kind of makes sense that the next one I'm going to show you is dereference operator. Okay. The dereference operator in C++ is the star. It's actually the same in C as well. These are actually, all these things I'm going to show you right now, these actually are stuff from the C programming language. C++ just copied them. They just inherited them as part of the language. Okay, so that's why they keep using them. These are also the things that make C++ powerful. The stuff that I'm showing you right now, you're not doing that in Python. You're not doing that in Java. You're not doing it in C#. You're not doing it in most of those languages. This is what separates C++ from most other languages, is the ability to do the kind of stuff that I'm showing you right now. Okay. The dereference operator basically does the opposite of what the reference operator does. Okay, so remember, when we talk about the reference operator, what it basically does is it allows you to suppress the second step. So if you give it a variable and you use the reference operator, it will return the address and it won't return the value. If you use the the dereference operator assumes that you're going to give it an address. And if you give it an address, it will give you the value stored at that address. That is what the dereference operator does. So, how do I want to demo this? So, if I were to come down here and do this again, my int, right? If I were to go ahead and put a star in front of that, well, immediately VS Code's probably going to be like sadness, right? You can't do that, right? Why? Because the dereference operator assumes that you're going to give it a memory address location. Well, if you just give it my int right now, what's that going to do? That's going to do a full evaluation. So it's going to come in here, it's going to find the memory address, and then it's going to find the value stored at that address. It's going to do both steps, and it's going to return this, right? And then this is going to try to operate on that, and it can't because the dereference operator needs to start with an address. So a nice easy way you can kind of prove this to yourself is, well, I have a nice operator that shows me how to get just the memory address. You can put the reference operator in front of it. And if you do that, hey, everything's great now. So what did I just do? I had the variable, right? I told it to use the reference operator, which meant that I basically just got just the address. And then just the address, I passed that to the dereference operator, which told me how to go get the value stored at that location. So I basically kind of went in a big circle. It's like a big old weird circle. Here, if we run it, here, I'll just live in Ubuntu today. Ubuntu is a little nicer for demonstrating this kind of stuff anyway, so I'll just kind of live there. All right, so here it is. First time I ran it, there was that one, the 5. There's the full evaluation. Here I am with the reference operator. That's why I got this big old memory address. And then the dereference operator, I went right back to 5. Why? Because I dereferenced it and then, I referenced it and then I dereferenced it, right? You could theoretically just keep doing that if you wanted, and then I could actually do the dereference of that, and then I could dereference that, and then I could do the reference of that, and then I could dereference that, right? You could actually just keep doing this all day long. I feel like that would be silly. Like you should probably, there's no really utility to do this, but there's nothing stopping you from doing this. One just undoes the other, right? That's all they're doing there. Here, watch. So the last thing you did, the thing that's on the furthest to the left, that's the last thing that's going to run as far as that operator is concerned, right? So in this case, it's the star, which means it's the dereference operator. So the last thing it's going to do is make it back to the value. So it's going to be a 5. If I get rid of that, the last thing I did now was the dereference or the reference operator, right? Which means I'm going to get an address. Okay, that's what they do. That's what they do. I'm gonna write down what I had here. I usually have a decent thing. Right. So if you have a memory address location, it will get you the contents. Maybe a better way of saying getting the value. That's what it does. I will leave this way. Hopefully this contextually makes sense why I did it this way. I'm demonstrating that you could only do it this way. Again, you can't just put that star right after this because then you would be trying to dereference like not a memory address and it won't work. So when does the unhappy marriage happens? When does the unhappy marriage happen? I don't know. I don't know. Hopefully it's always happy. I don't want it to be an unhappy marriage. I'm not a homewrecker. I want this to be happy. All right, so those are the 2 new operators I was talking about today, right? Understanding their relationship is going to be very useful to us when I start talking about the next thing I'm going to introduce today. Next stuff we're going to do. Two new data types. Data types is kind of implies some things here. I'm going to say There we go. Variable types. Let's go with that. 2 new variable types. Okay. So these were operators. So everything I just showed you here, these were operators. They operate on variables basically that already have been declared and initialized. That is what they do. They operate on stuff that already is in RAM. Now I'm going to talk about 2 new variable types. Okay. So now we're talking about when you're going to create a new variable, right, and introduce it into the program. I'm going to introduce 2 new ways you can do that. The first one I'm going to talk about is a reference type. This is in C++. This is also sometimes referred to as an alias. Okay. What is a reference type? So up here, I declared this variable called myInt, right? I still have my beautiful diagram over here showcasing it. So this is what I got going on in RAM. Normally, if I were to do something like int myIntRef, right, and set it equal to, I don't know, 42, of course, the answer to everything. Okay, so if I were to do this line of code now, what would happen in RAM? Well, what would happen is I'm introducing a new variable, right? So it would be myIntRef, right? And it's going to get a whole new location in RAM, right? Because it's a whole new variable. That's what the OS is going to give me. And I'm initializing it. I'm initializing it to 42. So which means that right here in the value at that location, I'm about to get a 42, right? All things are great. So what you can do, if you want, in C++, is you can actually create, this is just a normal integer. Sometimes you might want to be able to create a variable that references the same spot in the same memory address location as another variable. In that case, you can create a new variable as a reference type, and it will do that. And the only thing you have to change is when you're declaring the variable, you put an ampersand in front. Well, really, you just have to put it in between the data type and the variable name. If you put an ampersand anywhere in between that when you're declaring, doesn't really matter where. Look, I can put it like this and it's just as fine, right? It becomes a reference type. Now, I'm telling you that from the C++ compiler's perspective, it doesn't care where you put it. I'm going to tell you right now, like, you'll never see anybody do it that way. I mean, I've occasionally seen somebody do it this way, but I think it looks stupid. 99% of the time, you're going to see this or that, okay? And there's a lot of opinions about where it should go. I live in the camp where I think it should go here, next to the variable. I'm going to explain why in a minute, but on a technical level, it doesn't actually matter. All that really matters is that that ampersand shows up in between the name of your data type and your variable when you're declaring, and when that happens, you have created a reference type. Now, the first thing you might be noticing is that VS Code immediately, as soon as I put that ampersand in there, got upset about the fact that I was trying to assign 42. And it makes perfect sense once you understand what a reference type is. A reference type, like I just said, is a variable that references a spot in RAM that already exists. Okay? This is not a spot in RAM that already exists. This is just a number, which is why I am not allowed to assign it a value. In fact, if I try to compile this right now, I'm probably going to get a big old weird error telling me something about, I don't know. Yeah, L values probably, yeah. Can't do it. That's not a thing, right? This has to be, when you create an alias, when you create a reference type, you have to immediately assign it to a place in RAM that already exists. Well, lucky for me, I already have a place in RAM that already exists. This variable already has a spot in RAM, right? So if I want, I can say equals myInt. And if I do that, all is happy again. By doing this, what I have actually done is that it's not in RAM. We're going to represent this differently now. By putting that ampersand there and assigning it this way, what I've actually done is more like this. This goes away. It's more like this now. Oh no, I've messed up the I. Can I fix it? This is more of what's happening. I now have 2 variables that reference the same spot in RAM. Both myIntRef and myInt are both symbols now variable symbols that represent the exact same location in RAM. Okay? That is what a reference type does for you. You can kind of demonstrate this yourself by here. I'm gonna do some stuff, and I don't usually do this, but now that we're gonna start printing out lots of values, let's do this. IO manip. I don't usually like to use manip, but I think I'm gonna use the set with because sometimes the addresses start getting weird. So I'm gonna say I don't know set w2 or something. Just need them to be lined up. And I'm just going to print out all the data that I currently have. That way you guys can see them, next to each other. So we'll say, I don't know, my int equals, and we'll say my int. Okay, there's that, and then we'll do set with 2, and we'll do, let's say, my int ref equals, and we'll do my int ref. Okay. And here, just that by itself, let's see what we got. Okay. So we guys to see what it looks like. Oops. Gotta compile it first. Okay. And actually here, I'm going to get rid of this stuff up top. This stuff. I'm going to comment this out. Not because it's bad, but we've kind of moved past that. So now we're not talking about the operators now. Now we're just talking about a reference type. All right. Oh shoot, did I actually close the terminal? That was stupid. Wish I hadn't done that. Oh wait, it's back. Okay, go away. There it is. Alright, there's that and that. Okay, so here's the 5. Alright, that I had up top. Alright, that's what this guy was. I'm going to comment that out now, just so I don't have it cluttering up things. Sorry, I'm just trying to make this look as clear as I possibly can make it look on the terminal for you. Here's my int is equal to 5. My int ref is equal to 5. Right? They're both equal to 5. Well, you know what? That's probably the set width isn't working very well. I wonder if I increase it. I wonder if I set it to like 15 or something. I want it to go over a bit, and that way they line up better. There it goes. That lines up a little better. Okay, because I want everything on the other side of the equal sign to be lined up. So there we go. So now you notice how both these variables both are equal to 5, right? And you might be telling yourself like, well, okay, because you assign this to this, right? Well, actually, it's because they both have the same address. So here's what I'm going to do. I'm going to take this, copy it, paste that, and now I'm going to say I'm going to use the reference operator on both of them. Okay. Reference. Remember what the reference operator does. A little review of what I just said a minute ago. What does the reference operator do? It will retrieve the memory address of a variable, right? It basically will skip that second step. So now I'm just going to get the address. I'm going to print out these two will print out the values at those variables. These are going to print out the addresses of both those variables. Let's see what it looks like. Look, they both have 5 in it, but look, they both have the exact same address. That's because that's a reference variable. Right? It's a reference variable. So that's why they both are pointing to the same spot in RAM. Right? It might also be, and because of that, the consequence of that is that now if I do things like, oh, I don't know, my int equals 42 now, I'll just reprint all this out after I do that. All right, so all I did was I made the reference variable, I assigned it, I printed out what everything was, then I changed my int, and now I'm printing everything out again. And here, actually, before I do that, I'm going to do one thing. I'm going to put a new line right there, just so it separates a little easier on the terminal. Oh, and it put it on a new line. That's too funny. Okay. My int is now 42, but also my int ref is now 42. It changed it for both of them. Why? Because when I referenced this, when I assigned 42 to this variable, it went up here, it did the evaluation, it grabbed that address location, and then it updated it here, and it assigned it 42. And then when I came back down here, and I started printing everything out, right, and it started referencing my int ref, well, that was pointing to the same address, which means it's now 42 as well. Okay? So this is kind of how it's set up. That's what a reference variable does for you. Now I'm wondering if somebody's going to ask sort of the obvious question here. There's sort of an obvious question usually when I get to this point, right? I wonder how can I fix that to make it not do that. Maybe I should do. I'm waiting for it though. So that's the reference operator, or the reference type. Sorry, reference type, not the operator. This is the part that makes it very confusing for a lot of students. This subject that I'm getting into right now, this is where things start getting confusing for folks, and that's why I'm trying my best to break it down as simplistically as I can so that you understand the difference between these things. Because the good people who made C thought it would be a great idea to use these same symbols, this ampersand and this star, to mean completely different things when you're talking about operators as when you're talking about these new variable types. Notice how if you put the ampersand here, it means something completely different than if you use it as an operator. And that is very confusing for folks. It's very confusing. Nobody's asking the question. I'm really surprised, though. That is surprising. I'll give it one more second. The question. I'm looking at my notes, making sure I haven't missed anything so far anyway. Okay. Nobody's asking it, so I'm gonna go ahead and volunteer it for you. Okay. I'm surprised. Usually I get at least one person. Why would I ever want to do this? I mean, that's great. It has all this weird stuff where I'm assigning things and creating variables that point to the same places, I guess. I mean, like, what? But on a very practical level, like, why would I ever want to do this? Like, what is the utility of this? Of this having multiple variables pointing to the same spot? Like, I don't know why I would ever do that. Usually I get at least one student who's like, okay, cool, I guess. I've never needed to do that, and that seems silly. Why would I do that? So the answer to that question is actually the title of what I call this thing, efficiency. Right? And this is really what separates C and C++ from pretty much all the other languages in the world. Right? This is why it's a bedrock language. This is why you want to know how to do this if you want to write really efficient like code, is because C++ allows you to do things that most other languages simply won't let you do. And so to help demonstrate this, I'm going to use an example. All right, make a completely different example. So I'm going to make a function here, and hopefully I'm going to get a few more folks to participate. So I'm going to make a function. Here's what the function does. I'm going to call it add 10. And we'll say plus equals 10. Okay. And then down here, I'm going to say my int, I'm going to set it equal to, I don't know, what did I say, 5 earlier? Let's do 5. I'm going to call add 10. And then I'm going to say my int, and I'm going to see out, my int. Okay, $1 million question. What is going to get printed to the terminal right now with this code? If I run this right now, what is going to get printed to the terminal? Let's see who's awake still. Any takers? Who's feeling brave? Who is feeling brave? Nobody's feeling brave. You're all chicken. I'm wondering, can I goad you into participation? 5. Colby, I respect you, man. Respect you for putting it out there. 5. We got 1 5. What else we got? Anyway, I wonder if maybe what I'm actually waiting for is everybody's actually putting it into their compiler and just running it. Like, you're not actually just thinking about what you think should pop out. You're just like, oh, the computer spit that out. That's what'll come out. All right, Colby, we're gonna go with 5, and we're gonna see why. Now, and we're gonna talk about why. Why is the most important part of this. The fact that it does it is honestly not that all that useful. But why does it do what it's going to do? Let's find out. Right? And I suspect that some of you may be looking at this and being like, well, I mean, you're adding 10 to 5, so like 15 should pop out, right? Let's find out. The first thing I'm going to do is I'm going to get a compilation warning. Did I? Oh, I didn't return anything. I'm an idiot. Oh, that's right. I didn't want to do that. There we go. I didn't want to do it. That's why I didn't do that. I'm an idiot. Okay. Now let's do it. Helps if I write the code right the first time. There you go. And you are correct, sir. Yeah. You are correct. It is 5. Now, the real $1 million question here is, why is that 5? Because I suspect that at least some of you chickens who didn't respond, thought that this should probably come out with a 15. And let's follow that logic, shall we? So, when you declared this variable, you got my int and you got it set equal to 5, right? So we got exactly this right here. I'm going to get rid of that guy. Okay? So we had my int and it was set to 5 at some memory address location. That makes sense. Then we called a function, right? Now what happens when you call a function? Here's review time, right? And this is also kind of a point for me to re-emphasize what a parameter is, because I've noticed that this also sometimes people get a little like unclear about this. They think there's something magical about parameters. Parameters are not magical. Parameters are local variables. That's all they are. That's it. There's nothing else happening here. That's the entirety of their point. There is no difference between number and number 2 here, right? On a just practical, like they both are scoped exactly the same way. So number will die at the same time that number 2 dies, right? I can do stuff to both of them inside of the body. I can operate. There's no difference. The only thing that makes them any different from each other is how they get initialized. That is the only difference, right? So when I create a local variable like this, I have to initialize it. I should initialize it using, I don't know, like this, maybe 42 or something, right? Right? And this would create a new variable and initially assign 42 to it. Okay? And that all happens inside the scope of the add 10 function. Versus, here, I guess I'll leave it there. Versus this variable, this local variable, is a parameter. And when it gets initialized, the way it gets initialized is from the argument of the calling function. Right? So when this function gets called, you have to supply an argument. And that argument, the value of that argument, initializes this variable. Okay? So let's talk about, let's run through this. This happened and then this happened. So when this call happened, that meant that this function got called, which means that this variable got declared. Which means that in RAM, what just happened was a new variable was just created called number. It got assigned its own unique address location, right? And then how did it get initialized? Well, it got initialized using this variable, right? It got initialized from the argument. And how did it get the value of the argument? Well, it did a evaluation, didn't it? It evaluated the myInt variable. So what did it do? It went up here, grabbed that address space, and then it got the 5. And that 5 was then assigned, right, to this variable. So really, it's just like if you were to do any other kind of assignment operator. Like, I mean, I have this set up like this, but like if I did int x equaled 6 or something like that, the assignment operator works the same way. It takes whatever is on the right hand side, it makes a copy of that, and then it assigns it to whatever is on the left hand side. It assigns the copy of it. When you initialize a variable using a parameter and a function argument, it's basically like doing an assignment. You're going to take this value of this variable, you're going to evaluate it, you're going to take the value that you got from that, and you're going to copy that, and you're going to assign that copy to this. So what just happened to number? It got assigned the value from my int. So this came over here, and that became 5. Right? That's how it got initialized. Right? Then what did it do? I mean, we could say it did this. It added 10 to this variable. Okay? So let's add 10 to it. Boop. Now it's 15, right? And then what happened? The function ended. And when the function ended, what happened? All of the local variables for that function went out of scope. And when they go out of scope, they're gone, right? They get reallocated, or they can be reused by the program or the operating system for some other purpose. They might as well have just went as far as our program is concerned. We have no more access to that. So all of that just went away. This variable just went away. I have no more access to it, right? And then what happened? The function ended, and the control returned back down to line 26. And what happened here? It tried to see out whatever was in my int. Well, what's inside of my int? 5. 5 is still there, right? Nothing happened to my int. That's why 15 isn't popping out right now. That's why you only got 5 popping out. Now, why did I talk about all that? Frankly, that was just a little bit of review. But also, this allows me to talk about the thing that we took. Let's get rid of number 2. You always want to get rid of your number 2. It's a little dad humor for you there. Let's change one thing in our function definition now, right? I'm going to change one thing. Here's what I'm going to change. I'm going to now make this that. I added exactly one character to this program, right? I'm going to get rid of this. That was just there for demo. And let's run it and see what happens now. Only thing I changed is I added that ampersand. Now I get 15. Take away the ampersand. 5. Add the ampersand back in there. 15, right? Now, why is that? Well, what is this now? This is a reference type, right? I just turned the parameter from a regular variable type, right, the normal type that you're used to seeing, into a reference type. And what does a reference type do? A reference type points to the same address location in RAM from a variable that already existed. So what happened here? It used my int, right? My int was a spot that already existed in RAM. And so basically what I just did was when I put that ampersand in front, right? You can think of it as all of this going away now. By making an ampersand, number is like this now. And so then when I got inside of the function and I started adding things to number, well, when it tried to evaluate number, what did it do? It went up and found the address location associated with it, and then it found this. And then when I added 10 to it, what did I do? Oops. Come on, pen, come back to me. Come back to life. Oh boy. It added 10, right? Then the function ended. When the function ended, what happened? Number went away, but my int's still here, right? And then it came back down here. It re-entered this function. My int is still there, right? And when it went into evaluate, it came up here, and what's still sitting there? 15, right? That's what the reference variable is. Almost the most common way in which you'll ever see a reference variable is when you use it as a parameter. Now, when you do that, it has kind of a special name. So the normal way, the default way that variables are passed in C++, what parameters are defined in C++, is through a thing called pass by value, right? This is called passing by value. Sometimes we also call it calling by value. I learned it as pass by value, right? When you pass by value, it's just sort of the way that you've been using C++ up to this point. Everything is a copy. So when you get information from a call, it makes a copy of whatever was in your argument, and it copies that information into the variable that you have here. And then everything you're doing inside of that function with that parameter is a copy of the information. When you pass it by reference, that's what this is now called. Passing by reference is when you actually create your parameter as a reference type. And by doing that, you basically are reusing the data that was on this variable. You're creating another variable that points to the same location as this, right? And that's what allows you to be more efficient. Now, this might not seem like it's that big of a deal when you're talking about integers, because integers are tiny little things and who cares, right? They're not very big, right? But when you start talking about really big variables, like, oh, I don't know, let's make another one. Let's say we're talking about a string now, all right? And let's say I did something like this. Well, strings are not like primitive data types in C++. A string can hold a whole bunch of data, right? So I could theoretically do something like this. I could say, right? And I could just go on and on, right? I could type War and Peace into this variable, right? And then I could call print string and pass it War and Peace. And if I did that, what would happen is, well, frankly, this is a lot of data that's going to be in there, right? I could make this string humongous. And if I pass that by value, which is what I've done right here, then it's going to literally copy all of that data into another variable. So the way you would think of it is it would actually be like, here's War and Peace with a ton of data, right? And then you can almost think of it like, oh, and then it called the function, and then it made my string. So here's my string now. And it now has the same huge amount. I literally doubled the amount of space I just used up in RAM to basically just print something out into the terminal. That's not very efficient. That's actually terrible efficiency. You just ate up twice as much space as you needed for just holding some static information that's probably not going to change, right? That's a crappy setup. Better way to do it, pass it by reference. If you pass it by reference, then this isn't going to double it. It's just going to be a reference to the same exact location in RAM. So this is where efficiency comes into play. Now, there's other ways in which reference types are useful. This is probably the most practical way you'll see. Okay, but I'm just trying to make a point of like how this works, how this is set up. Any questions about this? I'll give you this code. Don't worry if I give you the code so you can see how it works. All right. If there's not any questions, I'll give it a second for the lag. Good old lag. I added another new line at the end here. I wonder if that would have actually changed anything. Let's find out. Hey, it did. It worked. That worked out nice. So now see how it was 42 twice? That's pretty good. Is there supposed to be no return type? Yeah, that me messing up right over here. Yeah. Didn't need a return type, right? Also note that you can then change. So you could almost think of this way of doing pass by reference. A lot of people use this as a way to not have a return value, because you can still get the value updated without having to do it. And there are advantages and disadvantages. We'll talk about that at a later date. I just want you guys to get comfortable with this idea. Okay. I said there was going to be 2 new variable types, but I only showed you one. All right, but I like to talk about this one because it has a lot of play in C++. Okay, let's do it. The moment you've all been waiting for. The second new variable type, pointers. This has all been a prelude, right? So what is a pointer? It's a new variable type, just like a reference type is. The most salient thing that you need to know about pointers, thing you should remember, if nothing else, from this entire lecture, I'll put it in all caps. Pointers always point to memory address locations. Okay? That's what a pointer basically is. A pointer is a special variable that you can create that points to a very specific type, but only that type's address. That's it. That's all pointer is. It's a thing that points to an address location for a particular type. Okay, so let's continue our little journey here. I'm going to create a new variable now, and I'm going to call it. I'm going to say int my int ptr for my int pointer, right? And if I did it this way, okay, this is just a classic integer. That's all that's happening here, right? Same old thing we've seen a million times. In fact, I'm going to clear this out a little bit. Get that ready for me to continue to do my drawings. My drawings. Don't need that to be that anymore though, okay? All right. So if I did this, this is going to be my int pointer, okay? This would just be a normal integer's worth of space in RAM. If I put a star in between the variable the data type and the name of the variable, if I put, just like I did for that ampersand, if I put it anywhere in between, this is now a pointer type. Okay, it is a completely different data type than an integer. Right, and to really highlight that, you can do something like this. Maybe you can do string my string ptr. Right, that's a string. Okay, that is a string pointer. A pointer to a string has nothing to do with a string, really. They are completely different data types. A string is a spot that is an address location that can hold string data, right? A pointer to a string, right, is a spot that holds the address location for the starting point for strings, right? It's an address, right? Again, you can put it in anywhere in between. I'm just going to do this for integers, by the way, because I don't want to. I'm just trying to keep it simple, right? You could do this either way. You're going to always see me put the star next to the data type. Why? Because pointers actually have to do with the type. The reference types actually have to do with the variable, right? In this case, I'm basically just creating a new variable that points to the same spot. It's all about the variable. In this case, it's all about the data. It's the type. So that's why you'll always see me put the star next to the integer, or next to the data type. When you do, let's see if I did this. If I tried to do now my int, immediately I'm going to have a problem, right? Why? Because pointers always point to memory address locations. And when it tries to do this assignment right now, what's it going to do? It's going to do a full evaluation. It's going to come up here to this spot. It's going to come here, and then it's going to come here. This is not a memory address location. It cannot assign a non-memory address location to a pointer, right? When it's a non-pointer, this would be fine. It would just be copying it, right? Everything's great. As soon as it becomes a pointer, we got a problem, right? Has to be an address location. So the simplest way I can demo how you could actually initialize the pointer is, well, we have that wonderful operator, the very first one I showed you. And what does it do? It gets the address location of a variable. So what can I do? I can get the address at my int. And now everyone's happy. Everyone's happy, right? So here we go. I'm going to copy all this and come on down here. And comment that out now. I'll give you this code, don't worry. And now we're going to say my int ptr ptr, okay? And then I'll come back to this if I need it. Okay, so here's what my int equals. Here's what my int pointer equals, okay? And then when I do my int ampersand, okay? So let's just take a look at what this did again. This is me referencing the address locations of them. So let's take a look, see what we got. My int is 5. My int pointer is the address. See how it's the address? So if I just print out my int pointer, right? The full evaluation of my int pointer is an address. So what pointers, the data portion of what, like the value of a pointer is an address location. So if you're going to draw this, this is what it would look like. When I created my int ptr and I initialized it, what did I initialize it to? I initialized it to the address of my int. So what's the address of my int? It's this guy. So what happened here? This is what is getting stored here, right? This is what it is. Now the difference here between this and like a reference type, remember, it's like you're creating a variable that points to the same location, right? So both variables are tied to the same address. Pointers are actual variables. That's why I put that star next to the data type. It's an actual variable that takes up its own spot in RAM. So a pointer actually has its own spot in RAM. It has its own address location, right? But the value stored at that address location is actually the address location of a different place, right? Which is why when we came over here and I printed my int pointer, right, and it did the full evaluation of my int pointer, what did it do here? It went in here, it said this variable, here's the full evaluation, get the address location and then get the value stored at that location. That was this, right? Then on the next line, what did I do? I used my reference operator to get the address location of my int. So I'd use the reference operator to get this location. So basically, this and this are the same, which is why when you come down and look at the values, this and this are the same. They're the exact same information. It's the same thing that's being stored there. Now the real trick here is that when I did the ampersand on my int pointer, right, when I did the reference operator on that, what I was getting was I was taking this, I was getting the address location of that pointer, and then that was it. I was not doing step 2, so I was just getting this address. This is a brand new address, which is why it looks nothing like the rest of them. Oh no, I got rid of it. Right? These two are the same. This is where that pointer lives. It lives on a completely different spot in RAM. Right? So that's the other thing you have to understand. Pointers are actual variables, like they actually have their own spot in RAM. Okay. Other thing we can talk about now, the other operator I gave you guys, that was the reference operator. What's the other one? The dereference operator. And what does the dereference operator do? Well, if you already have an address location, you can use the dereference operator to get the value at that location. And what do pointers always point to? They always point to addresses. So if I want, I can, and here's what I'll do. Do that. This time I'm going to do the dereference operator on my int pointer. Okay? Oh, I forgot to put the semicolon there. And let's see what that looks like now. There's the 5. My int pointer, this is the address, and it's the same as the address of my int, right? This is the address of the pointer itself, but when I dereference my int pointer, right? When I dereference this, it's like I'm dereferencing this location, which means it's like I'm dereferencing. Remember what the dereference operator does? It's like you give it an address. So when I gave it the address, which was basically just the value of this, it dereferenced it. So it went over and said, oh, I'm going to go look at memory address to 100 and find out what lives there. Oh, it's 5. So what popped out? 5. All right. So you can use pointers in conjunction with the dereference operator to be able to get access to the things that the pointer points to. Who's confused? I'm sure somebody is. I'm sure somebody is. And it's okay if you are. Pointers are notoriously one of the most difficult topics that computer science, like intro computer science students encounter. They all get really upset about them because they can be very confusing if you don't have them clear in your head. And what'll end up happening, and I hope it doesn't happen to you, but what a lot of people end up happening to them is that they get to a situation where they're using pointers, they don't really understand what's happening, and then they just start kind of flailing because their program doesn't work right, and they just start inserting ampersands and stars randomly in places because they just think, oh, it's somewhere, it's a star, an ampersand needs to go somewhere, right? Don't do that. Don't do that. That's a great way for you to just mess up your program worse and worse and worse, right? I laid it out this way because I want you to have a good understanding of these differences. These two are operators. I tried to explain exactly what those operators do. And then there's two reference types. There's two variable types, the reference type and pointer types. I guess maybe that would be a better way. Pointer types, right? Anytime you put in, the difference between those two really is that you're doing a type always has to do with when you're declaring a variable. So when you're declaring a variable and you use one of these, the ampersand or the star, then you're either creating a reference type or a pointer. If you're talking about a variable that already exists, like it's already been declared and now you're just going to do something with it, now you're talking about the operators, the reference operator or the dereference operator, right? Hopefully that makes sense. Understanding the relationship between those things allows you to be very efficient in C++, right? We're going to talk more and more about, this is just going to be stuff you're going to see a lot for the rest of the semester. You're going to see me using reference operators, dereference operators, and pointers frequently throughout the class. All right, so that's why this is my kind of introduction to it, to get comfortable with it, understand how they work, understand the difference between them, because it's going to come up and you're going to need to know. Last thing I'm going to do is I'm going to talk a little bit about some things that have to do with using pointers with member variables, or really with custom data types. Okay, so here's what I'm going to do. I'm going to go with, here we'll come down here. We'll just keep it down here. Okay, so you know that the string is not a primitive data type. It's a custom data type in C++. So I'm going to do my string, and I'm going to set it equal to, I don't know, hello world. Okay, now because it's a custom data type that was written by somebody else, the benefit of that is that it has a bunch of member functionality associated with strings. So if you just do my string and you use the dot operator and you have VS Code, look at all these member functions you get. It's a ton of them. So many, right? Pretty awesome, right? Okay. So remember, that's how you access member functionality or for an object, is by using the dot operator. So if I do dot length, let's say, right? Length is one of the member functions of string, right? And what it will give you, what this will return, is it will return the length of the string. So in this case, what do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's 11, right? So my expectation is if I were to do this, I should be getting back an 11. And here, I'm going to go ahead and comment this out for now. I'm going to give you this code, don't worry. Okay, that's what length does. Okay, so here's some stuff that's interesting to know about how pointers work. Now let's say the dot, well, let's just put it this way. The dot operator only works on values. You can't use the dot operator on a memory address location. You can't do it. So for instance, if I were to now make a variable that is of type string pointer, and I'll say, I don't know, my string ptr equals ampersand my string. Okay, so I'm pointing this pointer to the string. Okay, this works just fine. I can't do this. Dot length. Like, it won't let me do that. That's a no-go. No-go, right? The dot operator does not work on memory address locations. And here, if you do this, it'll see, you can't do that, okay? But sometimes you're going to have a pointer to an object, and you're going to want to be able to access its member functionality. So there's actually a few different ways you can do this. I'm going to show you sort of the ugly way to do it, right? So the ugly way to do it is if you want to keep using the dot operator, well, remember, the dot operator only works on values. It doesn't work on addresses. So if you want to do that, you can just turn this into a value, right? So how do you turn it into a value? Well, if you have an address location, let's go back up to the operators. If you have an address location and you want to get the value at that address location, you can use the dereference operator, right? So if you have a pointer which is pointing to an address location, you can dereference it, put that in parentheses, and then use the dot operator on that, and everything should be fine. It helps if you spell it correctly. There you go. Right. And now everyone's happy. Worked just fine. Okay. But that's kind of ugly. Not everyone wants to do that. That looks kind of silly, right? So if you don't want to do it this sort of the ugly way, right? The other way you can do it is using a new operator, and that's I'm going to use my string pointer. If you have basically an address, a memory address location, which is what this is, a pointer, you can kind of think of it as an address location because they always point to address locations, right? If you have that, you can use the new operator, the arrow. And if you do the arrow, now you have direct access to member functionality. Okay, so that's basically the difference. You use the dot operator when you want to access member functionality from an actual object. You use the arrow operator when you want to access member functionality from an address. Right. So if all you have is an address, this is obviously the slick. You're going to see this a lot more. Right. You could do it the other way around too. So like if you had, like my string is actually obviously it's a, here, my string. If I wanted to do my string arrow length, that's not going to work, right? Because my string isn't an address. This is a full evaluation. It's an actual thing, right? So if I do that, I'm going to get sadness. Can't do that. But you could actually do it the other way around. If you want to use the arrow operator, which I can't imagine why you'd want to do this, but if you wanted to, you just need to turn this into an address. So you can do the reference operator, put it around, parentheses, do it that way. And now it's an address. And if it's an address, you can use the arrow operator to get the information off of it. I know that seems a little hokey, but I'm just trying to demonstrate how those things work, right? So if you ever see a dot operator versus an arrow operator, that's the difference. That's what they're there for. All right. This is from non-pointer. This is a really bizarro way to do it. I would never expect anyone to see this, but technically it would work. Yeah, just weird. The other thing I want to talk about with pointers, and this is something that is a little bit of a difficult concept. I'm running low on time, so I'm going to try to get through this quickly, is the concept of having a pointer that points at nothing. All right. So we talked about this on day one, that in C++, if you do something like this, you declare a variable and you don't initialize it, that's a problem. It's actually called undefined behavior, and it's because there's no way for you to know what the C++ compiler is going to put as the value at that location. So for my little thing here where I just made X, right? If I don't declare it, who knows what'll be there, all right? It's not good. It's a bad situation to be in, bad behavior, right? So C++ sort of enforces this idea that you need to initialize your variables always, because if you don't, you have no way of knowing what's actually going to get put in there. However, when you have this thing called a pointer, sometimes you don't know what the pointer is going to point to. In fact, you might not, at the time that you're declaring the pointer variable, you may not actually have something to point it at that exact moment, right? So it puts you kind of in this awkward spot of sometimes I need to know that and I don't have that information now. In those situations, they have a special thing you can point pointers to. And this is special for pointers, makes them different than non-pointers. You can point them to, so let's say first I started it there, but now let's say I wanted to point it to nothing. You can point it to null pointer, right? Or more commonly, it's just called null, right? So this is a special keyword in C++ that basically evaluates to address location 0, which is not something that you're allowed to ever access, right? So it's a special spot in RAM, right, that they set aside specifically to denote null, which is basically their way of saying nothing, okay? So you can actually have a pointer that points at nothing. We actually have defined what nothing means for pointers, for address locations, right? And this is a handy thing. It comes in handy a lot, and this sometimes is hard for students to appreciate, this idea of pointers. So I have the last thing I'm going to show you here is I made a little program. I'm going to comment that out, but I just want you to be aware of it, what null does. I made a special little program that I called Squirt Gun, and it's really just to demonstrate why this matters, why this is important. So here's how Squirt Gun is set up. I've created a custom data type named targeted person, right? And basically it just represents a person that you're targeting for some reason. That person has a name, they have a team name, and the number of times they got hit, all right? And then I have a little member function that'll let you print out some of that information, okay? And then I have another custom data type called Squirt Gun. So the idea is that the Squirt Gun should be able to squirt a targeted person, okay? So your instinct might be when you're creating a member variable for this, would be like, okay, well then let's just have a targeted person, I don't know, the person or something, right? And that makes a lot of sense. And that then if I want to create a squirt gun, right, I could just say squirt gun, my squirt gun, I guess. And then I could say my squirt gun dot the person, right? Problem is that as soon as I ran this line of code, right, it's going to immediately it's going to declare this variable. It's going to set aside space in RAM for a targeted person, right? But we've all used a squirt gun before, I hope, right? You're not perpetually targeting sometimes you're not aiming the gun at anybody. Sometimes you're filling it up with water, or you set it down for a little bit and you're getting a drink of lemonade or doing something else, right? So there's some situations where you need to have this thing hold information, but that information is going to change. You're not always pointing at the exact same person. You might sometimes be pointing at other people, right, with your squirt gun. So what would make the most sense here is that you would want to have this be a pointer, right? Right? You're going to point your squirt gun at a targeted person. The other benefit of that is that if you didn't do it that way, right? Before I actually assign this to somebody, to the person equaling who knows what, until I do that, what this points to or what this represents is undefined behavior because I didn't initialize it, right? I need to initialize it, but I don't know what I'm supposed to initialize it to, right? Sort of a chicken and the egg situation. I need to have the thing, but I don't know what the thing's going to point to, right? So for a little while, I'm not going to point it at anybody. So if you make it a pointer, right, that problem gets immediately solved, right? Because pointers can point to nothing, right? So in this case, what would I do? I would just say, oh, it starts out pointing to nothing, right? And then later, I might have a targeted person named, Matt, right? And Matt dot name, I guess that's sort of silly, right? So let's TP for targeted person, right? So we'll do TP name is Matt, TP team name is losing team because I'm getting targeted, right? TP dot number of times hit. I got hit all kinds of times, 8 times, right? Right. And now I start out with this squirt gun pointing at nothing, right? But then at some point I might be like, oh, I'm targeting Matt because he's an easy target, right? So I'm going to be like, cool, my squirt gun dot the person equals TP. Except that I can't do TP, but I can point to the address of TP. And now I went from pointing to nothing to pointing to this object. And if there was a lot of targeted people out here, right? So let's say you had a bunch of them, right? You can just keep switching between one person and another person, and you're not having to allocate memory. You're not having to create new spots in RAM every time. You only need one of each of those targeted people, and then you're just pointing to each one that you're pointing at, right? You're not having to like create them and destroy them and then create and destroy and create. You're not, none of that's happening. All that data is just there, and you're just pointing to whichever one you need to point at any given moment. This is sort of the power of pointers. It's a very, very common strategy in low-level programming and C++ programming to allow you to do some very efficient things with memory that is a lot harder to do in many other languages that don't support that feature. Okay? So I'm just pointing it out, how you can use it. I'll give you this example in case you just want to play with it. I strongly encourage you to play with pointers and all how this stuff works. It will make your life easier. You guys have been awfully quiet. Is there any questions about anything I've done? All right. Give it a second. Let's talk about the homework while I wait for all those questions to roll in. Let's see here. This week, you got flowcharting. I already talked about this. So you're submitting it in Canvas. This is not an auto-grader assignment. You're submitting your flowchart in Canvas, and what you're doing is you're flowcharting out a diagram for hourly pay per week, or I think is it per week? I don't remember, per pay period, I guess, right? And it needs to also account for overtime, right? So this is just you doing a flowchart for me. And again, don't put in definitions of things. That really shouldn't be in a flowchart. That's not flow, that's structure. They're different. Next one you got, automated introspection. This one always makes me smile. So this is really the programming assignment you have this week that's really targeting all the stuff I talked about today. Okay, so it is a very contrived program I'm very specifically making you have to understand the reference operators, dereference, pointers, all that stuff. If you don't understand how any of that works, this program is going to drive you crazy, right? If you have a pretty good understanding of that, if you've been practicing or you were following along, honestly, this program, I don't know, maybe 20 lines of code, 30 lines. It's not a big program. It's actually a really small program. It's one of those things where if you know what you're doing, it's actually going to take you probably not very much code to write at all. If you don't know what you're doing, this is going to drive you nuts. Okay? So I would, again, like I said for the last week, and I'll keep saying it, don't wait till the last minute. Start on this immediately. So what you're going to want to do here is you're basically creating a function called makePhilosophical. And every time you call the function, you're going to give it a string, and then all that function is going to do is just append the phrase "right?" question mark at the end of it, and then you're going to call it, and then make some things philosophical or not. And then you'll make some decisions based on what comes back based on the length of things. You're going to need to know the length of the string. I already went over this during the lecture, but I put a little note in here as well. So you're going to need that length function again, right? So just as in case you didn't remember what I was talking about there, I also have it here too, right? But that's pretty much it. I'm a good person, right? This is edible, right? All right, so there's that one. The last one I'm going to talk about is good old no compile Kyle. So this is the first no compile Kyle for this class. If you've had me for a previous class, you've seen Kyle before. Well, he's back, and he's taking his hand at C++. For those of you who have not had me before, No Compile Kyle is a series of assignments that I give in my programming classes based on a fictitious character that I have created named Kyle. And Kyle is a very wonderful person. He's a very nice young man who does not know how to write syntactically correct code. He just does. It's beyond him. He doesn't know how to do it. Your job is to take his really crappy code and fix it. All right. I give these assignments in all my programming classes, and the reason I do is because it's my way of sort of reemphasizing what it would be like to work as a professional. Okay. Professionals rarely get to write like all the code for a project from scratch. Like that's extremely rare. That you'll almost never do that. It's far more likely that you're going to work somewhere where they have a product already. It's It's a lot of code, and your job is going to be going in and reading that code and making modifications to it, right? So you need to get in the habit. I want you to build the habit of reading other people's code. So in these assignments, I'm giving you code that was written by good old Kyle. Now, in a reality-based situation, you would probably never be looking at code that was like, that wouldn't even compile, right? So the other thing that these assignments do is it gives you an opportunity to practice your C++ syntax. Kyle is garbage at C++ syntax, right? He's lots of mistakes. Your job, fix all his mistakes, make it so the program works correctly, okay? And I give you example output to show you how the program is supposed to work, right? Once you get everything fixed. While Kyle is a crappy programmer, he's not good at the syntax, he's a pretty good commenter. He writes pretty decent comments. You usually can read his comments and understand what he was attempting to do. So this is yet another, emphasis of sort of a professional thing I'd like for you all to get in the habit of doing, commenting your code and the benefit of doing so, right? My hope here is by reading some of his terrible code, but seeing decent comments, it will give you a guiding light on what in the world he was trying to do, which emphasizes, hopefully, that it's useful for you to write good comments when you're writing your code, because you may not very well be the only person who looks at it later, and you don't want to be the Kyle for somebody else. You don't want them looking at the code you wrote and be like, what the heck does this do? What kind of garbage is this, right? Give them some good comments. At least it gives them some breadcrumbs to understand what you were trying to do. Even if it doesn't work right, they'll understand, okay? So I suggest you read the comments. Once you make a change to his code, I suggest you comment it, right? That is what you should do so that Kyle can read through this later and understand what the heck he did wrong. He's a sweet young man. Help him out. He needs your help, okay? It's an auto-grader assignment due on Tuesday. I don't see any questions. You guys were being super quiet today. I have a few more minutes. The last thing I'm going to talk about, this is just like I have it in my notes, it's a little tip. So those who watch to the very end, here's your little bonus tip, I guess, for C++. And obviously the Piazza post. Use Piazza. For crying out loud, use Piazza. Don't not. Also, your helpful resources are here too. These are supplementary to my lectures. I have a whole bunch of articles here talking about a lot of the same stuff I talked about today. Here's a little tip for you, because I know this sometimes people comes up. C++ compiler can sometimes be a real pain, right? Like sometimes you get like just a wall of errors back. Like you'll write something and you'll just get just an absurd number of errors back, right? And that sucks. And then you're trying to figure out which of those errors is the one that actually like matters. So sometimes you get something nice. Like in this case, like I probably would get just like a nice simple, nice. Oh, did that actually compile? Oh, because I'm in the wrong spot. Let's go over to Squirt-Gun. Right, so I get this one was a nice one, but sometimes you get like a wall of them, and it's really hard to know where the error is. Like it's in there, but it's buried in a big old pile of them. So here's a little trick you can do when you're compiling your code. Sometimes it comes in handy, and I figured I'd just share it with you guys. So you can send all kinds of compiler flags when you're compiling your code, and they do different things. But one that sometimes comes up for folks that's really nice is this. So when you're doing it like this, you can do G++. You're always going to want to pass in the C++11, because that's the one I'm grading you against, so you should always put that in. But another one you can put in is this. It's dash, and I'm going to make sure I write it right, W fatal. Okay? Fatal dash errors, sorry. Fatal errors. If you do that, what this flag will do is if you have a ton of errors, it will only display the last error. And honestly, the last error is almost always the one that you're looking for, because that's the one that happened first. I know it's the last one that pops out, but it's the first one that your compiler ran into. And 99% of the time, it's the leading problem. It's the problem that actually happened. So if you do that, it will actually just print that out first. See, in this case, it was the same thing. It didn't really actually matter. Compilation, but see here it says compilation terminated due to this error. So basically what happens is the second it finds that error, it stops compiling. And then it just prints out the very first error it ran into, which 99% of the time is the one that you it was the actual problem, and then it helps you target it a lot faster. So it's just a little tip. You can do this. I find that sometimes my students benefit from being able to just see that, and I know that oftentimes when you're writing your programs, you get a wall of errors, and just a little tip for getting through that. I'll hang out for just one more minute in case there's any other questions, but if there's not, that's pretty much what I have for today. If that was not enough, we got plenty of it. We're going to be doing lots and lots of pointers. Thing that's actually probably worth mentioning too, just as an aside, what I'm teaching you guys right now, all this stuff with this stuff, these are what in kind of modern times people would refer to as a raw pointer. This right here, down here. These are raw pointers. Raw pointers is kind of like the industry's way of saying C pointers, like pointers that are like the low-level pointer that you get in C++ because it's actually part of the C programming language. Modern programmers, modern C++ programmers usually don't use raw pointers. It's sort of controversial. A lot of people don't. Some people do. The reason is that it's very, very, very easy to make mistakes with raw pointers. It's very, very easy, as I just kind of showcased that there's a lot going on there, and if you don't really understand what you're doing, it's very easy to mess something up. So to get around that, the language has adopted what are now referred to as smart pointers, and there's a whole bunch of them that exist. And if we were in like an industry right now and we were like writing a production product, I probably would tell you never to use a raw pointer, because most of the time, like I would say like easily 90% of the time, they're more trouble than they're worth, and they're not necessary for what you're doing. A smart pointer would probably be better. However, we're not an industry, and we're building, in this class, fundamental computer science data structures. That's what this whole class is going to be about. For the fundamental data structures, raw pointers are the appropriate thing to use, which is why I'm teaching them to you. But I do like to kind of mention that, so if you want to just learn some more C++ on your own, I'm not going to cover it, but if you want to just learn it some more on your own because you're interested, I might suggest Googling smart pointers in C++, and I'm sure you'll find a plethora of people out there who are willing to share how they work. So with like unique pointers and shared pointers and all that stuff, they're very useful. They're kind of what the industry would expect from you. Again, this isn't really a C++ class, so that's why I'm not worried about focusing on that. But I know a lot of you are interested, and so since we're talking about this now, I figured I'd share that with you. All right, that's all I got for today. As if that wasn't enough, thank you all for hanging in there. I did wish I got a little more participation, but I'm guessing you were all just sitting there absorbing the information, so that's what I'm going to tell myself. We'll meet again next Thursday. Until then, have a wonderful rest of your week. Hopefully I'll see you on Piazza, and don't wait on getting the homework done. Get started now. Until then, adios.